Hello, I'm Carla Lauterin. I'm here with GeoWeek News, and we are talking with the CEO of Navis, and we're going to talk all about the past, present, and future of what they're up to and what they see is on the horizon for reality capture. So thank you, Felix, for joining us today. How you doing?
Thanks a lot for having me. It's a pleasure. I'm doing very well, and I'm sending greetings here from Munich, Germany.
Oh, wonderful. I wanted to ask, just for people who might not be familiar with your company, can you give us like a little bit of a history of kind of how you got to what you're doing now and kind of what your bread and butter is in the industry?
Sure, Carla. So Navis is now 8 years old. We were originally founded as a spin-off from Technical University back in 2013. And that research itself goes back even to 2007 and earlier. And it was always research in the field of 3D data capture, computer vision, with kind of a larger idea behind that is still driving and has been kind of the North Star for the whole development of Navis, that we've got this digital twin of our outdoor world, let me call it like that, you know. Everything that has been going on in the GIS world, where every square meter of outdoor space is scanned with satellites from airplanes and with drones, and then transformed in layers of digital maps that then themselves build the foundation for all kinds of applications that have become integral parts of our daily lives. Car sharing, food delivery, ride hailing. In the future, it's going to be autonomous driving. And what our mission has always been was to rebuild this infrastructure to some extent for the indoor space. Because today, both satellite positioning and as well, all the satellite or plane-based data capture doesn't work in buildings. And we thought, wow, buildings, that must be an even larger market, because that's where we spend 85% of our time. That's where almost 90% of our GDP is being created. So what we tried throughout that time is taking technology mainly from artificial intelligence, robotics, take these new sensors, LiDAR and camera technology that became smaller and smaller, to build a technology that could rebuild the stack that we're enjoying outdoors every day and make it specific for the indoor world. And by now we are around 250 people located in Munich with offices in New York, in LA, in Shanghai. Gonna be extending to a couple of additional markets soon, dedicated to that mission. And we started with the reality capture part. Many of the audience might be aware of our VLX product, but we of course really come from the software side, and the Navis Ivion and Ivion Go products are then the approach, like, do not only create this data, but as well make it really approachable. And perhaps the analog moment in the outdoor world for many of us users was Google Maps, you know, when suddenly the GIS data moved away from living only in expert tools, but becoming really an integral part of everyone's daily life, because it became so easy to use and interact that data. And once that level of abstraction was introduced, then all these other business models could really start emerging, you know, the ride sharing and the food delivery and the scooters and all that good stuff.
So when you speak about, you know, kind of that ease of use and that customer usability, can you talk about how SLAM LiDAR played a part in that? Because it definitely differs from that expert-driven, you know, traditional laser scanning that was really in expert hands up until recently.
Yeah. Yes, I think perhaps, you know, if in the industry we could nominate a word of the year, I think SLAM would have been up and running candidate for quite some years. And of course, the idea is absolutely striking. You know, you don't collect data just from one stable point, which has been a fundamental part of how you measure it over decades, perhaps even hundreds of years. Find a very, very stable point and then, you know, measure from there the next point. And SLAM introduces a fundamentally new paradigm, which is you are measuring all the time while you're moving. And of course, if you could master that, you could, of course, be many, many times faster. And on top of that, having the huge advantage that people totally underestimate, that you would see everything that you want to observe and measure from a lot more perspectives. And by doing that, triangulate a lot more. And then last but not least, of course, it has in itself, a lot of elements of automating what you would anyway be doing by connecting several single point measurements. It would just be totally and immediately done by the algorithm itself. And of course, by doing so, you might be taking out some of the special expertise and making it easier to adopt. So at the end, SLAM was always this promise. And I think it was very, very clear for people that if you could make it work, it would be beneficial from so many different perspectives, from an efficiency perspective, but as well from a perspective of information theory, seeing things from more different perspectives, and last but not least, making the technology of measuring at high quality more accessible. And I think now we are really seeing that all these original promises start to be really delivered to a more mainstream market. And then that's kind of what really changed, I think, over the last 12, 24 months.
Yeah, and that was the next thing I was going to ask you is, do you think we've reached that point now for those people who were using, SLAM when it first came out or had some doubts, how far have we really come?
Look, I think it was a couple of tough years, like with many fundamentally new technologies. And you can look at pretty much everything, from flat LCD TVs to now what we are seeing with VR, augmented reality. Like the first approaches usually look a bit disappointing, even though everyone agrees on how exciting the technology is in general. And we've now seen that for almost a decade. The first somehow viable SLAM devices came out already 10 years ago. And then we've been working with the technology for 10 years in prototypes and in early products. But what has really changed over the last 2 years is that I think now the technology is really ready for the larger market. And a couple of things needed to come together for that. The first thing is, of course, and that's perhaps even the most important, is reliability.
Right.
I think under certain good circumstances, SLAM was already delivering pretty good results since a couple of years. But unfortunately, there were many cases that were hard to somehow predict where it was not working. And that, of course, is absolutely unacceptable if you really want to build a business out of that. And that just took quite some time, to understand these corner cases and really kind of hone that technology to a point where, it would be really applicable in pretty much all cases. Or if there would be something breaking, the technology would give you some kind of good feedback that you would need to redo something, or so that the workflow would start to be really reliable. And that is, I think, it comes based on two things. The first, that we've now these multi-layer LiDAR systems, that we get better in merging different SLAMs, like LiDAR SLAM, visual SLAM, inertial SLAM. And then, of course, huge progress on the algorithmic side. So these things over many years have come together, and suddenly, you have a little bit of this iPhone moment where you suddenly have products that have that reliability. And that's kind of the first and most important thing. I think now with VLX, but with a couple of other products as well, you have products that you can absolutely reliably work with. Right. The second big thing, I think, is, of course, precision. People liked already some lower accuracy SLAM devices for some time, but it was entirely different market. It was rather, people were exploring new use cases with that. And suddenly, SLAM-based scanning has reached a level of accuracy. And that's not only accuracy in terms of absolute result, but measurable and controllable accuracy. That at least covers what I would say is 80% of what people are doing with terrestrial laser scanning today. Of course, there are still applications where terrestrial laser scanning is far better. But I think the latest generation, like VLX second generation, 80% of what our customers have been doing with terrestrial laser scanners can now perfectly be replaced with the VLX second generation. While, of course, you are a hell of a lot faster and it's kind of easier, and you will cut your field time down to 10% what it used to be, and the whole workflow going to be a lot easier. And you can tie this into existing control points so that you can really double check and make sure it's right.
Right.
And that element, there was always this element, partially that's part of the reliability thing, where it felt random. You know, it was really difficult for a professional to know if a SLAM result was good or not. And by now combining SLAM with a couple of the principles that were always used in surveying, that, so to say, adds a lot to the accuracy thing. There is more absolute accuracy, but that's now really measurable and checkable accuracy. And then last but not least, I think SLAM has been coming a long way as well in terms of the overall workflow. You know, how are the devices built? I think we've learned quite a lot in, you know, what works and what doesn't work out in the field. We had these trolley-based systems. We believe, look, 95% of all space in buildings should be easily accessible, so a trolley should be great. Reality is, it just doesn't work. There's too many stairs and small rooms, and then you want to scan on construction sites and you want to go indoor and outdoor, and it just turned out that trolley-based designs just are too limited, with a few very small niche exceptions. And now everything is becoming wearable. I think that's a big trend. And of course, there was a lot of stuff, you know, I think people learned that backpacks are actually not very good because you have very sensitive sensors, and the backpack, you have the sensors behind you. If you are moving through tight environments, you might easily damage your sensors. People learned that it's really important to have the screen with the real-time feedback in front of you, because remember, you know, SLAM might not be so reliable in every condition. So it's super, super important that you get a feedback immediately if something is not right and you can correct. So I think this usability element in terms of the whole workflow, does the data that's at the end being created fit into your standard tools? Can you work with the stuff in the field? I think that is now as well on a level where people start really feeling comfortable with it.
Yeah, absolutely. And I think, as you mentioned too, that there's a lot of these construction and architectural engineering, you know, use cases, but also I think that VLX form factor, especially in some of the use cases that we've talked about on our site, has opened that up into other industries. Can you talk a little bit about some of the potential other applications? In other words, and also because they're GNSS denied, you know, where you can take them in places that TLS can't go.
I think in general, you can pretty much do everything with the TLS. And I don't think that SLAM-based devices will totally substitute TLS. And then bluntly, my recommendation would still be, if you start a scanning business and you only have money, so to say, for one device, I would still recommend that in many cases you start with the TLS, because it's very versatile.
Right.
However, once you start moving and you want to capture larger spaces efficiently, then of course, I think you should not buy 2 or 3 or 4 TLSs, you know, to just get faster, but instead buy VLX second generation, because you know, that is immediately adding what it would take in terms of 3 or 4 additional terrestrial laser scanners. And of course, you are much, much more efficient in terms of additional personnel. So your annual cost base stays a lot lower. It's a lot lower investment compared to buying several TLS scanner. And I think something that is was very, very important for us is that the VLX is designed in a way, as well the whole workflow, that you can easily combine TLS data with our SLAM data. And so that you can actually combine the best of both worlds. And perhaps to go even one step further, what is the kind of work where I would still recommend to use the TLS, and where would I say VLX is a better tool? So for all basic work around creating the models up to LOD 300, I would say pretty much always use a VLX. There might be, you know, certain high and steep facades that you can't easily scan with a VLX, where a TLS with larger range, you know, you might find a good angle where you can actually capture the whole facade. That's kind of one area, and the other area is when you really want to go and you know, have very delicate tubes and details of of equipment in buildings. And there, of course, it depends a lot if you really want to go more for the engineering tasks, where you really need the detail, or if it's more like really the BIM modeling task, where I think kind of a VLX is 100% capable by now of doing that. So that is as well, you know, I think telling a bit of a story of what the best workflow then is,
Right.
which is if you can do everything with the VLX, I think you will always be more cost efficient. And then the second best choice is, you know, add these few spots, you know, that you can't yet really do well, and fit in a TLS. And the joint workflow will still be a hell lot faster than a workflow only be based on TLS scans.
Absolutely. And I think, you know, and that's a point that doesn't get driven home much, is the ability to bring in those different levels of detail into, you know, one model in the end that helps you get what you needed, but without having to pick just one tool for the entire thing. So that's
exactly
like,
that's what you're saying, the right tool for the right job. And if you're a professional craftsman, you would very likely work with more than one tool.
Right, exactly.
Or it becomes really awkward, you know, there might be people that can do amazing things with that one tool, but then it's rather more on the artistic than on the efficient side.
And obviously that's playing into future workflows for things like digital twins, and eventually, you know, kind of bigger things like what's making the news now, the metaverse and uses in augmented reality. How do you kind of see reality capture kind of playing a part in that? And where do you see Navis as being positioned in there as well?
But I think what's definitely true is that we're seeing two big trends, you know, the classic workflows and topics that we are, you know, serving in or serving with laser scanning or reality capture, to use a more broader term, they are still out there and they are expanding, and they have a need to become, you know, more efficient and as well, you know, perhaps be a little bit less reliant on very scarce expert personnel. And I think that's a trend we are totally catering towards with the VLX and with SLAM more general. And of course, the pandemic has driven that a lot, but there are other mega trends. You know, BIM in general is still kind of developing as a topic. And for example, in Germany, we have a whole set of new regulation around BIM, specifically in state-driven construction work. And the adoption is still only in the first quarter, perhaps. Right. And then if we go all the way, you know, we still build 80% in existing buildings. You know, 80% of all construction money is spent somehow in rebuilding, extending, changing existing buildings, compared to only 20% in new buildings. So just creating BIM models and, you know, have a good starting point for all that part of the construction market will drive huge demand in the coming years. And then, of course, reality capture plays more and more of a role in construction monitoring and construction verification. This is just getting started, you know, and that, of course, will drive huge amounts of square meters, because there you are not only scanning things once, you want to scan them very regular. Right. And then, of course, combine these two things, you know, not only have a great BIM model and good reality capture, but really overlay these two and make sure everything is going according to plan. And you identify deviations early so that you can fix early. So the later you fix, things will become 10 or even kind of 2 orders of magnitude more expensive. So you really want to find these deviations early. So I think all this is just kind of really made for SLAM, you know, to scale and to help people in these existing workflows or just emerging workflows to, you know, do their work better and make their customers even happier. And then you're absolutely right. You know, we have an entire new breed of kind of topics of business models and or business ideas coming. And some of them, I think, are already further down the road. So the whole idea of digital twins, of course, more than just a BIM model, it's a living digital representation of the physical entity. I think where people have been struggling there with is it's great to have a model. But then, of course, the building ages, you know, even more the equipment, and even more if you're in environments that are really valuable. So factories, hospitals, a lot changes, and people have found it almost impossible to do that and keep that reality and model in sync with a pure push basis. So let me just put an example, you have the plumber coming, doing some replumbing, and then you expect the plumber to change the BIM model.
Right.
Or, you have someone repairing the roof, and then you expect that person, to update your BIM model. That just turned out in reality to be totally unrealistic.
Right.
And people have made all kinds of ideas. Every RFP needs to include that people do that update, but then in reality, a lot is done by your own in-house people. And who has ever tried it came to the conclusion that the pure push principle still leads to a huge deviation between the model and the reality over time. And that is really dangerous, because if the data becomes unreliable, it is untrustworthy, and then it's really dangerous to build up on that data. So a different mechanism needs to be there and needs to be put in place that is not only push, but as well pull. And that's exactly what reality capture does. And for that to really work, of course, the reality capture mechanism needs to be really, really cost efficient. Because otherwise, you rather try to save that cost, and then you run into trouble once you want to rely on that model that wasn't updated. So the synchronization mechanism is a very, very important part of the whole idea of a digital twin. And I think reality capture is a really important part to play there. And you see, like, everything that happens outdoor is not built on the push principle as well. Google is not waiting for the city council to give them notice that a certain street has changed. That would just not work. Google is just using all the data that's out there to rescan, and I think that is what absolutely needs to happen around buildings as well. And then we, after the digital twin, we move into even more, let's say, untested waters. But it's of course stuff everyone in the industry believes, and billions, even tens of billions of dollars are right now being invested because people believe in the potential of this, and that is augmented reality, and then perhaps even larger mental concept, the metaverse. So augmented reality at the end means that you overlay every piece of physical reality with additional digital information that we have stored. And of course, it's very closely related to the digital twin concept. Because where is this overlay coming from, if not from some kind of persistent digital copy of reality that tells you which piece of content relates to which piece of physical reality? And again, if your digital twin is not up to date, it's not going to be a good experience. So that is why, for me, the digital twin is even like the foundational element of the great large-scale persistent augmented reality experience. And of course, I don't even want to recap all the exciting opportunities and possibilities with augmented reality. And it's a good reason why Apple and other market leaders say that they believe the augmented reality is going to be the next big compute platform and going to be a lot larger than virtual reality, for example. And everything that happens on the shop floor in any building, I think, will be tied to the digital version of that physical asset. And augmented reality is exactly, where these two worlds come together. The physical, which is still so fundamental for us humans. We're not going to be living in a futuristic digital-only world. We still want our physical experiences. The real world still going to be the most important thing for us. But of course, in the digital overlay, a lot of things will become a lot more transactional efficient, very convenient. And so I think at the interplay of digital and physical is where a lot of the really interesting use cases going to be. And then reality capture or spatial data is exactly what keeps these two worlds in sync and makes these use cases really valuable. And then in the metaverse, it's just many of these things. Not only one overlay, but a bazillion of different overlays and different worlds. And of course, some of them will live just for themselves, like pure fantasy worlds where you can have fun. But again, I think the economic most relevant will be the one that overlay with our real physical world somewhere. And again, that's exactly, where you need to think these two worlds. And yes, you can wait for the pure push. But if you want to make this experience reliable, I think there is a lot of really very regular syncing, and reality capture is exactly that between these two worlds that needs to happen. And that is one of the fundamental building blocks of this whole augmented reality and then metaverse concept to ever work and ever become economically viable. And So if we already believe that there is a lot to do in the traditional use cases, kind of the BIM and construction monitoring and verification, and that is already going to be driving huge growth into this market, and that has really waited for SLAM, so to say,
right.
to come and make things more efficient. These new use cases, that's going to bring the whole industry even on a totally different trajectory.
Right.
And we already see that today. If you want even smaller scale augmented reality or metaverse experiences to work, that has already driven a demand for our technology. Even though, of course, it's still early stage and still a few years away from being a mainstream thing. I think people are starting to invest, starting to try things out, and I'm really looking forward to, supporting the players with spatial technology and reality capture on their way.
And I will say too that even when I first started in this industry, it was kind of like, okay, the reality capture has very specific uses. These people use it. It's over here, and it's like this genre that's by itself. And to see it evolve and get to a point where it can be such a crucial part of these things that are now, front page news about the metaverse and those things, it's really been fascinating to see that evolution in the direction that's capable, because these technologies are getting better, they're getting more accurate, like you said, more easy for non-experts to use. So I'm kind of, to keep your future hat on for a moment, what do you envision kind of reality capture or reality capture workflows to look like in the future? Are you evolving as this technology is getting better? I know you guys went, like you mentioned earlier, from the mobile form factor to the wearable, the VLX second generation. Kind of as your company evolves, what are you doing to kind of keep up with or lead the industry?
Look, I think one big fundamental change that comes with SLAM is the primate of software. And in the classical measurement world, very, very good mechanics was the most important thing to nail, to drive precision and as well as speed. And that is really, really changing with SLAM. This is fundamentally and foremost driven by software. And a lot of the quality in the data and everything that SLAM can do better as well in the whole workflow comes from software. And so I think that is as well kind of really change in mindset, so to say, for many people that have been working in the industry for many, many years. So what does that mean? So of course, that doesn't mean that there is nothing changing on the hardware side. So sensor is going to be smaller and even more capable. We've seen that already on the camera side, where good cameras were kind of heavy on glass and metal. And now just look what an iPhone can do, or any modern smartphone. Tiny, tiny little lenses. Usually you have several of them, and then a lot of computational photography. And you've got results that would have been even impossible to do with the largest pieces of glass just kind of a couple of years ago. And of course, we are trying to combine visual and photogrammetric elements with LiDAR SLAM. And on the LiDAR side, I think we are seeing the same. LiDAR used to be really, really large. It gets smaller and smaller and smaller, driven by autonomous driving, robotics, other trends as well. So I think you don't need to be a wizard to forecast that, SLAM-driven reality capture devices will get smaller and more compact. And by that, they will allow even kind of different and new form factors. And I think the industry isn't played out yet in coming out and trying out different form factors that will overall all be smaller and more versatile. So I think that's on the hardware side. But then the real magic is faster and faster the data will immediately go to the cloud. And that is kind of where, out of what you even have in sensors today, still a hell lot more can be made. And just let me use this very simple analogy. We humans, our sensory package is actually not very good in terms of pure pixel accuracy. A modern camera does already a lot more than that. But then just look what we can actually make out of that, because our image processing is so ridiculously good. And I think that gives a little bit of the potential that is in software, mainly, of course, in artificial intelligence, but as well in the whole workflow. While you're scanning, And that will be coming with Wi-Fi, which is still difficult, of course, on many construction sites, but with 5G, 6G, data will immediately go while you're still scanning to the cloud. And there you will, run kind of a multi-staged post-processing very fast to see first results, more or less real time, but as well very sophisticated to squeeze out the last bit of quality out of a still reasonably affordable sensor package. And then, of course, a lot of manual or semi-manual work steps of today will be more automated. And that has to do with combining different data sets, geo-registration, alignment, quality assurance, data security law, making sure that you don't have people license plates or other kind of objects in the data, automatically removing dynamic data or kind of all kind of artifacts from mirrors and whatever is there. And then even doing some kind of first segmentation and providing the foundations for later modeling work in a more automated way. Segmenting floors, walls, doors, certain pieces of furniture, doing all that more automatically. To some extent, even tying to databases of objects that are already stored in your library, in your favorite modeling tool, making suggestions so that what I said earlier, the synchronization between reality and the model world that you have will be more and more fully automatic. And I think that is something that's still a long process today. You record the data. If you work with a TLS, you still have to puzzle all the pieces together. You have to run all the quality assurance. You have to clean the data. You have to compress the data. Then you have to move the data over into your modeling tools, and then you start the modeling or comparing the model with reality. So I think there's still a very, very long workflow with many pieces that are really in urgent need. And I think everyone in the industry would agree for further automation and simplification.
Yeah, wonderful. And all of those technologies that you speak are definitely, you can see the need and you can see the people trying to get in, to fix those problems, those road bumps on that workflow. And it's going to be really interesting to see how automation and AI kind of plays a part in that in the future as well. And I think, on that future vision, we'll probably wrap it up there. But thank you again, Felix, for your time here. We're really looking forward to seeing what the future holds. And we appreciate your coming to talk to us today.
Thank you so much, Carla, for having me. It was a pleasure. Yes, I'm very excited about the future. And I think we have already a lot of very, very cool stuff happening in our research teams and R&D teams. And very, very happy to show that to a broader audience in the next months and years.
Awesome. Thank you so much, Felix.